this for you. Okay, Eric. Okay. Here's the thing. Bubbles are made out of soap, right? Like one time we were at before we weren't able to celebrate Christmas with people. Can't do that now. We're I guess near the Ventura Mission. They have like snow coming. They have snow from the Christmas tree. Snow comes and everyone's all, oh yeah, beautiful snow. You know what I found out? I found out that snow was actually bubbles. I was all, I'm out of here. I cannot. It's like bubbles all over. All over you. I am out of here. I cannot get away. I don't want these bubbles. I can't stand the bubbles. And my kids are like laughing. All my family knows I don't like bubbles. They're just like, Dad's not gonna like this. It's bubbles. I'm out of here. And I stood way back and let you guys get all the bubbles you want. I don't want the bubbles. So bubbles are like soap, right? They're soap. You guys know what soap is? I mean, I like soap, but soap is it's a medium to like collect dirt, right? And soap is good because it collects dirt. But do you ever wash your hands with soap and then just leave the soap on your hands and then start walking around? That's disgusting. That's just keeping dirt on your hands. Like that. That's what bubbles are. Just soap getting all over your body and all the dirt getting on you. That's what it is. Oh, God. I'm thinking about it like, I'm cringing. So like when we're at the Christmas thing, they pop. That's right, Jasmine. They pop, but you still have soap scum all over you. Ugh, disgusting. There's still don't get me started on any of you guys swimmers or water polo players over there? Anyone? Okay, no one.
I'm not, but I like swimming.
You like what?
Swimming. I like, like the thing.
Yeah. I got you. Give me another one of my. I was gonna go off another one of my pet peeve rants, but I'm not going to. Oh, you should, Jose. You should join the water polo team. I'm telling you. Water polo is. I'll tell you something. Water polo people who play water polo are probably like the toughest people I know. Because I mean, can you imagine treading water that whole time for like hours and hours? That's crazy. You're gonna be buff, Jose. Do it. You'll be buff. Okay, so let's get onto the review. I haven't even taken roll yet. Actually, let's take roll. Okay, here we go. Rolly roll. Okay, Donnell. Isaac.
Here.
Ishi.
Here.
Madison.
Here.
Kayla.
Here.
John.
Here.
Alex. Garcia.
Here.
Jasmine.
Here.
Matthew.
Here.
Brandon. Morella.
Here.
Here.
Joshua.
Here.
Annika. Eric.
Here.
Gracie.
Here.
Carlos.
Here.
Jose.
Here.
Ethan.
Here.
Natalia.
Here.
Jaylene.
Here.
Giovanna. Taylor.
Here.
Jay. Gianna.
Here.
Jacob. Roberto.
Here.
Ariana.
Ariana.
Did I say it wrong? Ariana?
Yeah, I'm here.
I'm sorry. Ariana. I say Ariana. Ariana. I'm sorry, Ariana. Okay. Okay. No, that's cool. Thanks for correcting me. Okay. Here's how I've absent. Donnell Abir, John Chavola, Brandon Grijalva, Annika Hulskamp, Giovanna Ruiz, and Jay Singh. Donnell, are you there? Okay. John?
I'm here.
All right. Brandon?
Yeah, I'm here.
Annika?
Here.
Jay?
I'm here.
All right. So Giovanna. I feel like Giovanna was absent yesterday too. Check my email. Okay, let's get started on this. Let's get started on this review, okay? Got a lot to go over, but then we'll be done. We'll be ready. An error has occurred. Oh, I can't share my screen. Okay, I guess class is over. I can't share my screen. Okay, let's start with chapter 7. All right, here we go. Chapter 7. No, we did 7. We did this already, right? We did 7. Series. We need to do 8. Sorry, let's do 8. Okay, here we go. All right, sorry. Okay, here's what I'm gonna do. My screen presentation is not working, so just pretend like you can see it. Just listen carefully to what I have to say, and then we'll just do what we can. Okay. So on my screen it says a right triangle theta is an acute angle. Sine theta equals 4/7. Evaluate the other 5 trigonometric functions of theta. Okay, so we just have to evaluate that. So we have here sine. So I'm writing down sine theta equals 4/7. I'm sorry you can't see it, but I don't know. We'll make do. Hopefully you can. I don't know what to say. So I'm just gonna go ahead and do the best that I can. See if you can learn with your ears and not your eyes, since you cannot see me writing here. I'm sorry you can't see me writing, but anyway, we're gonna say sine theta equals 4/7. So we're gonna say sine theta. This is trigonometry, and our trigonometry tool is what Goku says. Goku says SOHCAHTOA, right? So we have to figure out sine, cosine, tangent, and secant, cosecant, and cotangent. So based on SOHCAHTOA, let's see, sine of theta is, and I'm writing this down, so I know you can't see it, but just pretend like you can see it, is opposite over hypotenuse. Cosine, I'm writing the word cosine theta, and I'm writing the word is adjacent over hypotenuse. And then tan theta, I'm writing the word tan, and theta is opposite over adjacent, okay? And then, but we have here cosecant also. Cosecant, I'm writing the word cosecant theta, is the same as 1/sine theta. Okay, cosecant theta is 1/sine, which is basically this flipped, hypotenuse over opposite. Secant theta is equal to 1/cosine theta. So you just flip this. Adjacent over hypotenuse. And it's hypotenuse over adjacent is secant theta. And then cotan theta is 1/tan theta, and that is adjacent over opposite. That's cotan. All right. All right. Okay. All right. So, okay, are we doing okay? Since you can't see my screen, you guys learning through air? Okay. Jay, are you doing okay? Is it okay if they can't see my screen?
Yeah, we can see your screen.
You can see it?
Yeah.
Ah, okay, cool. That makes life a lot easier, doesn't it? Look, I can put my head. Oh my gosh, I'm looking at I have a big nose. I didn't even realize how big my nose was until I put it in front of the camera. Oh my gosh. Okay, get out of here, Lucas. Okay, so what was I saying? So we got to figure out sine opposite over hypotenuse. If I'm only given sine theta is equal to 4/7, so let's draw a picture, shall we? Can I fit the picture? You know, like those bubble guns, the guns that shoot bubbles, that would work on me. Isn't that weird? Like they seem like playing pretend, but I'd be all, oh my gosh, get away from me. And I would run. I'd rather have a real gun. Okay, theta. So we have here what's given to us. Sine of theta equals 4/7. So let's draw the picture, right? Sine is opposite over hypotenuse. Opposite 4/hypotenuse 7. We almost have everything that we need to know to solve for everything. We just have to solve for this side right here. We use that doing the Pythagorean theorem. A squared plus B squared equals C squared, or 4 squared. Let's call this X right here, plus X squared equals 7 squared. 4 squared is 16. 49. Subtract 16 on both sides. X squared equals 33. And take the square root, and x equals a square root of 33. So this is a square root of 33. Now we have everything that we need to know to solve this. Okay? Sine, cosine, tangent, cosecant, secant, cotangent. Okay, sine of theta is opposite over hypotenuse. Sine of theta is opposite over hypotenuse, which equals, we have that, sorry, 4/7. Sorry, I have that. Cosine of theta is adjacent right here. Can you see this? Adjacent over hypotenuse, which is root 33/7. Tangent, oh, it's getting a little crazy here, is opposite over adjacent, which is 4/√33. Watch carefully. 4/√33. I cannot have a square root in a denominator. Okay, so we got to get rid of that square root. Remember, to get rid of the square root, we multiply it by itself. Square root 33 over square root 33, which equals, I'm going to write in a different color, 4 times square root of 33 all over. Square root 33 times square root of 33 is just 33. Okay? Now, cosecant is just this flipped. Cosecant is hypotenuse over opposite, which would be 7/4. Secant will be hypotenuse over adjacent, which is what? Which is 7/√33. But I can't have root 33 in the denominator, so I multiply by root 33 and root 33, which equals 7/√33/33. Okay, whatever. And then cotan is adjacent over opposite, which would be root 33/4. And those are all your answers. I'm circling all final answers in orange. Orange, 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 and orange. Those are all your final answers. Go ahead and write them down. Okay, are there any questions? I'm sorry you had to hear that. I'm sorry. Hopefully your parents weren't listening to me yelling. I was so mad that I got kicked off. Did one of you do that? Did one of you kick me off? Okay. All right, so that's that. See, your internet connection isn't great, is what it says. Am I synced up though? Sync is on. Okay. Well, let's see. If I lose connection, I guess we're out. Okay, let's do that. Let's keep going. Okay, there's the answers to the ones that we did, official answers. Can you guys see that? I don't even know if you can see it now. Jay, can you see this? Am I presenting?
Yeah, I can.
All right, thanks, man. Okay, we're not going to do any of these. Okay. Okay, looks at draw an angle with a given measure in standard position. Okay, it's 240 degrees. Okay, so let's just draw a 240-degree angle, and then let's see if we can find the reference angle. I'm just going to show you, but the picture, I think you guys get the idea. But 240 degrees would be somewhere over here. You have to identify this in a multiple choice test. So this would be 240 degrees. The reference angle is 60 degrees, right? Madison, do you know how I got that 60 degrees there?
I think so, yeah.
How did I get it?
The only problem you run into is Alabama.
Sorry, I'm trying to figure it out.
I'm going to keep it here. You probably need to see the picture, Madison. But let's go with Brandon. Help Madison out here. Wait. Side files when you're offline. No thanks. Brandon, help Madison out.
It's because half a circle is 180 degrees.
Yeah, keep going.
And then you have to add the 60.
Yes. Do you see that, Madison? This is 180 here, and then you get an extra 60. So the way you figure that out is you subtract 180 from 240.
Yep.
Okay, cool. I'm moving on. Here's another one. 500-degree angle. How would we draw that? Find the standard position, and what is the reference angle, right? So 500 degrees would look like this. We start here. See the red? We go around once, and then here we hit 360. We're not at 500 yet. How much more? Well, 140 more would be 500 degrees. So this reference angle is 140 degrees. How do we figure that out? How do we figure that out? Right? Let's see. How do I figure out the 140 with that? Eric Jones, go ahead. I'll get back to the picture here, Eric.
What was the question?
Gianna, help Eric out. Eric, stay with me. Keep your microphone on. Gianna's going to tell you the answer.
Subtract from 360, or you subtract 500 from 360.
Yes, very good. Got it, Eric?
No, I couldn't hear.
You didn't hear what Gianna said?
No.
Gianna, say it again.
You subtract 360 from 500.
All right. I asked, how do you get 140 degrees? With me, Eric Jones?
Yeah.
All right. I can't even see you. Let me see you. Are you even paying? Are you eating? Are you in bed or anything like that?
No, right here on my desk.
Okay, leave your camera on because I think you're like not paying attention, especially if you can answer the question. You too, Brandon. You can see I can't see you, Brandon. Can you see that? You're just a big B. There you go. Very good. Okay. Okay. Find one positive angle and one negative angle that are coterminal with negative 45 degrees and 395. So you want to find the same, they're like the same angle, but they're just on top of it, basically. So coterminal means that, right, I have negative 45 degrees. Another angle that would be on the same place but is not negative 45 degrees would be 315 degrees. How'd I get that? 360 minus 45. If I went in this direction, that'd be 315. If I go in this direction, that's negative 45. Then I can go twice around negative 45 plus minus 360. I get negative 405, right? I keep going. And I take away another 360, and I get that because I'm going backwards. I take away because I'm going backwards. Are there any questions on that? Because we're going to move on to chapter 9 next. You're going to love 9.
Wait, I had a question for the 240 angle. So if you were to find the coterminal for a number that's less than 360,
Wait, hang on. This one here.
Yeah. So if the
coterminal, okay, I'm sorry, say your question again. I'm sorry. Go ahead.
So if the number is less than 360, you have to find a number which adds to that angle equals 360.
So coterminal, like, let's get our definitions right. And let me see if that answers your question, Jay. You see, Jay, how this like is just opening, right? I start here and I open up to here, right? Does that make sense? Okay. Now, could I keep spinning this thing around and around and around and around and around? This ray right here?
Yeah.
Sure, why not? Spin, spin, spin. Now, let's say spin it here and I stop, right? Okay. But what if I keep going and I spin it all the way around and then it hits that spot again? That's a different angle.
Yeah.
But it lies on the same line, so we call it coterminal angles. So if I went here and stopped and then I went another 360 degrees, I add 360 to 240, which would be, I think, 600 degrees. And the coterminal angle here would be 600 degrees, which I go all the way. I could do another one, which would be 960. And I can go another one again and add another 360. So that's a coterminal angle. Do you understand that?
Yeah.
Okay. Now this right here, this 60 degrees is a reference angle. It's just from the 180 to here. It's as if this was the angle from here to here. That's the reference angle.
Oh, okay.
So the reason why the reference angle is important is because I can use sine, cosine, or tangent with this 60 degrees to find the either length of this side or this side if I was given a side length or a degree. So I think coterminal is spinning on, it's the same angle, but reference angle. Like if I had one here, like here, this is 500 degrees. The reference angle would be from here to here, from here to here. Oh, shoot. From here to here. So this reference angle would be 40 degrees. Right here, this would be 40 degrees because my angles are here. It's my reference angle.
Okay.
But these are coterminal angles, the 500 and the 140. They're like the same line, but the 500 spin an extra time around. All right, Jay, are you good? Jay? Jay, are you live?
Sorry, my Wi-Fi went out for a sec.
Oh my gosh. My Wi-Fi went out too. Did you see it got kicked off? Okay. You guys remember law of sines and law of cosines? Anyone? Don't say anything if you remember them. You see, I'm trying to find my... All right, I had it written down. Okay, wait a minute. No, okay. I guess I have to write it down. Okay, oh no. Ah, here we go. I found it. Okay, law of sines, law of cosines. Am I sharing? I think I'm sharing. Okay, law of sines. You guys remember law of sines? Sorry, for some reason my handwriting's extra chicken scratchy today, but sorry. Anyway, law of sines is sine A over A equals sine B over B. Law of cosines is c squared equals a squared plus b squared minus 2ab cosine c. You guys remember that? Law of sines, law of cosines. We're going to do a couple of those problems today. One law of sines, one law of cosines. If you guys want, actually, I should ask you guys if you want me to do law of sines, law of cosines problem. I'll leave it there for a second, and I will look at you and see if you guys want me to do law of sines, law of cosines problems. Majority wins, okay? There's a law of sines, law of cosines. If you need to write it down, write it down. You can also look it up. I'm sure it's not that hard. Just Google law of sines, Google law of cosines. Okay, I'm going to remove this in 10 seconds. 3, 2, 1. Okay. All right. Raise your hand if you want me to do law of sines, law of cosines. Like physically raise your hand. Let me see. Okay, I'll do law of sines first, and I'll do law of cosines. My last class did not want me to do law of cosines, but I'll do it. If you guys want me to do both, I'll do law of sines first, and you guys can be all, oh yeah, okay, that's cool. Okay, so we have here. Now, the thing is, law of sines, you're working with an opposite side, opposite angle. Remember that? You have to have opposite side, opposite angle, given or solving for. Law of cosines is 3 sides and an angle. 3 sides and an angle. All right? So, here's our picture. I'm going to draw the picture. Let me make it big for you guys to see. Do you guys pin my presentation? All right, so here is my, I'm just drawing the picture with my ruler right now. Question, as you're looking at this, do we use the law of sines or the law of cosines here? Law of sines or law of cosines? Anyone want to yell it out as I'm writing this and talking at the same time? Okay, there we go. I drew it. All right, fine. I'll call. What do you think? Law of sines or law of cosines? That's the main thing, because you're going to have test questions or using law of sines or law of cosines. What do you think, Jacob? 50-50 chance. You can just guess if you don't know.
Wait. So, I'm gonna say law of cosines.
Wait, what'd you say?
Law of sines.
Yes, very good, Jacob. That's exactly right. You're 100% on. You're on fire, man. Don't even stop. Jacob is right. He said law of sines because he saw that I have opposite side, opposite angle. Opposite side. Oh, no. How do I find this opposite angle? Is it possible? Here's my calculator. Isaac, how do I find that opposite side?
Can you repeat the question?
How do I find this? I'm sorry. How do I find this opposite angle right here? How do I find that angle?
You add up everything you add up everything in the triangle and then subtract it by 180.
Very good. Okay, so we have 48 degrees. So now Jacob said law of sines, opposite side, opposite angle, opposite side, opposite angle, opposite side. So we just go sine 48 over A equals sine 25 over 15. And then you just solve it. Remember, we just go cross multiply sine 25 A equals sine 48 15 times 15, right? I want to get A by itself, so I divide by sine 25. A equals sine, can you guys see? Let me get rid of this little thing here and then move up. Okay. So these cancel out. Sine 25, A equals sine 48 times 15 divided by sine 25. If you want to practice with your calculator, now would be a good time. So I'm going to enter all this in my calculator, right? Remember that? So all you have to do is hit sine 48, do close parentheses, times 15, and then you can do equals, divided by sine 25, close parentheses. I like to close the parentheses just to make sure everything works out. 26.37. Okay. And then you can solve for this side by using law of sines also. All right, is that good? Let's see. I'm going to put all this here. Can you see everything? Try to get it all in. Okay, I'm going to remove this in 10 seconds unless anyone needs it. Oh, yeah. 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 Okay, 5, 4, 3, 2, 1. Okay, law of cosines. Let's find a law of cosines. If you can identify one, see 26.4. I got 26.37. I was right. And then you can use law of sine to solve for C. But look here, I want to do a law of cosines one here. Look at 1, 2, 3 sides and an angle. Law of cosines. Okay, so we're going to use law of cosines for this one. Law of cosine. So I'm going to draw this. I'm drawing the triangle as you guys are just hanging out. You guys can draw the triangle too for the review. Again, I got to get this. I'll post this to you guys. I don't get a lot of hits on my recordings anyway, but get a couple. Not enough to quit my job. I think I could be a YouTube star with all my math videos that I do. YouTube. TikTok math. Are there any TikTok math people? And do people do? I don't even know how to use. Oh, there are. I don't even know how to use TikTok. I don't even know how that really works. I think people just. It's like a 30-second thing. They just flop around or something, right? Flop it. How do you flop a math problem in like 30 seconds? Okay, law of cosines. So since I have this angle, I'm going to make everything equal to B. So I'm going to say, I'll do it in orange. B squared equals A squared plus C squared minus 2AC cosine big B. So let's plug it in. B squared equals A squared. Doesn't matter, 11 or 14. 11 squared plus 14 squared minus 2 times 11 times 14 cosine. You guys see that? 34. I'm running out of room. So B squared, here we go again. B squared equals 121. I don't know what 14 squared is. I got to punch it in. 14 times 14. 196 minus 2 times 11 times 14. $308. 308 cosine 34. Okay, now I don't subtract these because you have to multiply this first. You can add these, but let's do negative 308 cosine 34. Let's figure that out. Or 308 cosine 34. 308 times 308 times cosine 34 close parentheses equals 255.34. So let's write everything down. 121 plus 196. Now this is all multiplied out, so I can say plus, it's a positive number, 255.34. And so I'm just keep it in there. I'm gonna add 196 and 121. 196 plus 121 equals 572. B squared equals 572.3435. There's a point right there. And then you got to get the square root on both sides. So second square root plug in the answer. Is that going to work? 23.92. B equals 23.92. And that's all you got to do. I'm gonna leave it there for a second. I gotta check my answer though. Make sure I'm right. Checking my answer. 7.9. What did I do wrong? Let me see. 121, 196. Let me check my cosine. Am I in degrees? Cosine, so 308 times cosine 34. Is it 34? 255 plus 196 plus 121. Huh. What did I do wrong? Wait, is it? Am I looking at the right problem? Yeah. I did this earlier today. What did I do wrong? Wait a minute. 2 times 11 times 14. 308. Oh, shoot. I forgot to subtract. This is subtraction. That's a subtraction there. 121, 196 minus 255. That's what I did wrong. Sorry. 121 plus 196 minus 255.34 equals 61.66 second square root second answer. Boom, boom. 7.9. There we go. That's better. I forgot to subtract. Oh my gosh. There you go. All right. Are there any questions on that? I'm ready to move on.
No.
Okay. Thank you, Ariana. Appreciate it. All right. I'm going to get rid of this in 10 seconds. 5, 4, 3, 2, 1. So that's, I mean, all the rest are the law of sines and law of cosines. So let me get the next one. I'm missing something here. I graph of sine and cosine. No, hang on. I didn't get something here. It's 7, 8. Oh, I forgot all this. Degrees to radians or radians to degrees. Does anyone need me to show you how to do that? How to convert from degrees to radians or radians to degrees? Raise your hand if you want me to show you how to do that. Degrees to radians or radians to degrees.
I feel like we should have that in our notes, so I think we'll be fine.
Yeah, but I think a lot of people raise their hand. It'll take me a second to do, Ariana. Okay, so degrees to radians. All it is, it's right there. 120 degrees, 120 degrees. Let's change that to radians, okay? All you have to do is multiply it by 180 degrees, pi over 180 degrees, right? I want to change it to radians, so I put the pi on top. Change to radians, so this goes like this. That cancels out. Equals 120 pi over 180, and then you just reduce. Am I not presenting? Shoot. There it is. So 120 degrees. I want to multiply by pi over 180 because I want to change it to radians. So I put the radians on top. Okay. So these cancel out. So 120 over 180. The zeros cancel out. 12 over 18 are both divisible by 6. So it's 2 pi over 3. I divide 12 by 6 and 18 by 6. So 120 degrees is 2 pi over 3 radians. That's how you do it very quickly. Okay, and then another quick one. Let's see. Then we have radians to degrees. Negative pi over 12 is equal to degrees. To get rid of, we want it to be in degrees. So now I put the degrees on top. 180 degrees over pi. Instead of pi over 180 degrees, 100 degrees is 180 degrees over pi. Guess what that does? That cancels out the pi. And now it's 180 divided by 12. So what's 180 divided by 12? I don't know. I was punching the calculator. 180 divided by 12. 15. Boom. So it's negative 15 degrees. That's how you do it. Any questions? We'll move on. Any questions?
No.
All right. Anyone else? Okay. I'm getting rid of. Let's see. Here you go, homies. Last thing. Anyone want me to show you how to graph 2 sine 4x plus 3? 2 sine 4x plus 3. Graphing a sine function. Raise your hand if you'd like me to show you how to graph a sine function. Okay. I only see 2 hands. Okay. So if you want me to do it, I'll do it after class. Okay. Let me go back to Sharon. And so we're almost done here. So we'll do the sine function after class if you guys want it. We're doing chapter 10. Chapter 10 is not that big of a deal. I think I'm presenting right now. Watch this. I'm just going to explain it, okay? What's a probability? P means probability of x being less than mu plus sigma. Well, where's mu plus sigma? Right here. What's the probability that x is less than that? Well, it's everything less than that. So you got to change these to decimals, but 34% plus 34% plus 13.5% plus 2.35% plus 0.15%. You add all those up because those are all less than mu plus sigma. And then you change it to a decimal and you get 0.84. Let me know if you need me to explain that in more depth. Probability means if it said percentage, you'd leave it in percentage. So to add the percentages up and then change it to a probability, change to a decimal. Okay. Are there any questions? I can be more in depth in explaining that if you want me to. Oh, Lucas, come on. Okay. Now, this one, what's the probability that I go mu minus, x is between mu minus sigma and mu plus sigma, right here. Mu minus sigma to mu plus sigma, it's these two. 34 plus 34 is 68. Put it in 68%, change the decimal, 0.68. There you go. Okay. That's it. That's all I have. Anyone who wants, are there any questions on what I just did with those? Oh, no, you know what? There's something else. Actually, there's something else on that. You guys remember parameters and statistics? Remember that? So, and population and samples. Forgot about that. Okay. Determine if this is a population or a sample, right? Remember, population is everything. Sample is just a part of it. The age of each dentist in the United States. Is that a population or a sample? The age of each dentist in the United States. Is that a population or a sample? What do you think, Grace? Okay, thank you, Jay. Okay, Jay was ready to move on. Awesome. Jay got fast because of that. Thank you, Jay. How about determine the data? Is this a population or a sample? Survey of 100 spectators at a sporting event with 1,800 spectators. Someone else besides Jay, so we can get out of here. Is that a population or a sample? 100 spectators out of 180, or out of 1,800 spectators.
A sample.
Very good. It's a sample because it's not all of them. Okay, so next, almost done here. A parameter or a statistic. Remember, parameter is the data from a population. A statistic is the data from a sample. Okay, so this is a parameter statistic. For all students taking the SAT in a recent year, the mean mathematics score was 514. Is the mean score a parameter or a statistic? All right, what do you guys think?
Parameter.
Parameter, thank you, because it says all. And that's it. Okay, you guys, go ahead. If you want to stay for the graphing sign, you may. Otherwise, you guys can go. I love you. I will see you when I see you. Bye, Matthew. Bye, Carlos. Bye, Jose. Remember, we're taking the cast tomorrow. The cast tomorrow. Be ready to take it. Bye, Gianna. Bye, Gracie. Bye, Roberto. Bye, Morella.
Bye, Sensei.
Bye, Kayla. Bye, Ariana. Okay, so are these the sample people who want the sample? Strummer, I can't see you. Wait, Strummer's in my... Strummer, what are you doing here?
Wait,
Is Str-
for
Oh. Wait, Strummer, are you in my last class? I
yeah,
feel
I
like
had a
I'm in the...
question. I was waiting for
I feel like I'm in the Twilight Zone right now. You're like throwing me off.
no,
Okay.
I just had a question.
Okay. Well, I'm gonna go over these guys with the I'm gonna show them how to graph sign real quick, okay? Because that's what they're
Okay.
saying, and then I'll answer your question.
Mhm.
Okay, right, Jay, Natalia, Eric, and John. You guys cool with that?
I was just gonna ask a question.
Oh, you have a quick question, John?
I can say after that.
Okay. So Jay, Natalia, and Eric. All right, Natalia's nodding. Eric, I'm assuming yes, Eric. Okay, and Jay, right?
Yeah.
Give me a nod, Jay. Okay, cool. All right, here we go. The graphing 2 sine 4x plus 3. Okay, this may take about 5 to 7 minutes, I'm guessing. Okay, so g of x is equal to 2 sine 4x plus 3. Okay, before we graph this, I'd like to graph over here y equals sine of x. Okay, sine of x. I'm going to graph 2 periods. Okay, so sine of x, I'm going to go up to 1, go down to -1. I'm going to make each of these pi over 2. So this will be 2 pi over... Am I not presenting?
Yeah, you're not presenting.
Oh, man.
No, you're not.
Here we go. Always forget that. Okay, so I'm going to graph 2 sine 4x plus 3. So basically, what are these parameters doing? I have 2, I have 4, I have 3, right? What's it doing to the sine? So in order to see it, let's graph a regular sine graph. Okay, so I started my graph up to 1, -1. I'm doing my scaling it by pi over 2. So this will be 2 pi over 2, which is just pi, 3 pi over 2, 4 pi over 2, which is 2 pi, 5 pi over 2, 6 pi over 2, which is 3 pi, 7 pi over 2, and 8 pi over 2, which is 4 pi. Okay, now, sine of x, if you look at the unit circle, okay, my zeros of sine, remember the sine is the y, is at 0 degrees, and then at pi is 0 degrees, and then back at 360 is also, here at 360 is also 0 degrees. So, graphing sine, I have 0 at 0, 0 at pi, and 0 at 2 pi. 360 is 2 pi. Sorry about that. Does that make sense? How I got those zeros? And I need my 5 key points. So I graph the zeros first. You guys good with that? Jay, you good with that? Natalia?
Yeah.
Yes.
Maybe Natalia's not there. So then I know I go up 1 because pi over 2 is 1, and 3 pi over 2 is -1, and it's just going to look like this. Here's my sign. Let's do my 5 key points again. 0, 0, and 0, right? You get the zeros, and then you go up 1, and then down 1, and it goes like this. So that's sine. Okay. But we want to graph 2 sine 4x plus 3. What do these parameters mean? So let's do, okay, how do we do this? The 2 is the amplitude. The amplitude is 2. That means from the midline up, it's going to go not up 1, but it's going to go up 2. It's going to bring it up. The period, that's how fast it goes around the circle once. This one, the period is finished at 2 pi. The way we figure out the period is 2 pi divided by b, where my b is 4. So it's 2 pi over 4, or simplified, pi over 2. That means I got to go around the whole circle by this point right here. I have to go up, down, back up again at pi over 2. That's how fast I have to spin it. And then finally, the midline is at 3. That's this right here. The midline is at 3. So that means this is midline at 0. So that means at 3 is going to be my midline. Okay, so all that, we're going to use that, and then we just graph the sine function. Okay, so now the scaling is going to be different. And so we have here, I want to get done at pi. I want to finish my whole cycle at pi over 2. So what I'm going to do is I want to get my 5 points in. 1, 2, 3, 4, 5. Right here. I'm going to expand my graph and make pi over 2 right there. So look at the fourth one I go over is pi over 2. That'll give me my 5 points. Then we go over here. 1, 2, 3, 4, 5. So 4 over again is going to now be pi. Okay? So that way I can finish one whole cycle right there. I can fit my 5 points in there. It's going to be beautiful. And then I also want my midline. You can see here my midline is at 3 and my amplitude's at 2. So I want to go up to at least 3. 1, 2, 3. Right? There's my midline. Let's draw the midline. I should make the midline. Let's make it green. So right here's where my midline is going to be. There's my midline. And then my amplitude is 2. So that means I got to go up to 4, 5. So I'm going to go all the way up to 5, all the way down to 1 for my amplitude. Okay, so let's do our 5 key points. So remember, if we look at our graph here, we go 0, 0, 0, and we finish the 0 at the period. Remember my period, my third 0 is going to be here because I want to finish by 2 pi, or pi over 2. So I got 0, 0, 0. Every other ones, right? You got your 3 zeros. And then you go above and below. Now, oh, by the way, it's right here because that's my midline is at 3. So I do my zeros there. My period is here, so I got to finish by pi over 2. And my amplitude is up 2. So then, remember now I go up here. Well, I'm going to go up, not 1, but 2 because of my amplitude. Down 2. There we go. There's one period. Then let's do again. Let's do another period. I got my 5 key points, starting with this one, even though I'm here, 0, 0, and then I finish at pi, because that's my other pi over 2. Pi over 2 plus pi over 2 is pi. And I go up 2, I go down 2, and then you go like that. Remember, it goes on forever. It goes on forever. Those are supposed to be arrows. That's it. That's how you graph 2 sine 4x plus 3. I'll keep it there so you can see. I just want to see who's still there. There it is. Ugh. All right. Are there any questions on that? All right. You guys have any other questions?
Mr. Sanchez, I wanted a little bit more help with the co-terminals.
Okay. Okay, I'll get that. Let me see. Eric, you had a question. Do you have, or do you want to keep waiting? I don't know who wants to go next. Eric, you've been waiting, so I feel like I should ask you since I haven't helped you yet.
I'm fine just learning about the co-terminals more because that was the one I was kind of confused about.
Okay, cool. All right, cool. Let's see. I'm not good at drawing circles, so actually, I'm trying to think of how I can explain it better. Let's say that's 45 degrees. Okay. Now, if I was to, like, if this angle opened up, you spin it
You're not
counterclock. Am I not presenting?
No.
No.
All right. Okay. Can you see it now?
Yeah.
Okay. So let's say this is 45 degrees. I start here, and I if it was a clock, it'd be going backwards, but I go this much, it's spun 45 degrees of the whole thing. If you go all the way around, it's 360. Now let's say I do an orange one. I can do another angle that spins around. Where am I at so far, Jay? At this point?
90 degrees.
90. Keep going down here. John, how about that? How many degrees have I gone? Is it John? Wait, who else is there? John, yeah. John, are you there?
Yeah.
So how many degrees have I gone there?
180.
Yep, okay. Keep going. We're at 270, right?
Yeah.
Now keep going. 360, right?
Yeah.
Okay. Jay?
Yeah.
Okay. Then I go here and I stop here. How many degrees have I gone?
$405.
Yeah, 405 degrees. Jay, are you with me?
Yeah.
So I spun around 405 degrees. That angle, I see this also as an angle that's spun around more than once, and that angle is also a 405 degree angle. It seems weird, but I just opened twice. You can call it that. That 405 degree angle is a different angle than my 45 degree angle. Do you see how it's a different degree, different angle? Jay?
Yeah.
So I kind of did like, that's a different angle, that orange one. It's a different angle, but it's right on top of the same ray as the 45 degree angle. They're both, so at this line, there's two angles. It looks like one angle, but because they're two, it's a coterminal angle. I have one angle that's 45 degrees. The other angle that's on top of it, that's coterminal, is 405 degrees. And I can find another coterminal angle by taking 405 and adding 360 to that. And so you'd have a third coterminal angle at 765, right? 765. There's another angle on top of it that's 765 degrees. And then I can add another 360. I can get another one on there. Keep spinning around. All right, did that clear it up, Jay and John?
Oh, I just need to ask a question.
Oh, wait, is it Jay and Eric that have the question?
Yeah. It was
Jay,
me.
I know Jay was asking. Jay, did that clear it up for you?
Yeah, mostly.
Mostly, okay. Well, hang on, let's keep going. Eric, how about you? Were you asking about the coterminals too?
Yeah, I just have another question. So if the question was asking like, what's the coterminal of 45? The answer would be 405.
Yeah, you just keep adding 360.
Okay.
Or you subtract 360. Or you add another 360 plus 360. Or you add 360. You keep adding 360s. You can keep getting coterminal angles.
So all those answers would be right?
Yeah.
All right. Okay.
So the multiple choice will probably just have you add 360 or take away 360. Just one.
Okay.
Okay. Jay, you said kind of you understand?
Yeah, I just had a question for there's one example problem. There was like find one positive angle and one negative angle.
Yeah. So you can subtract 360 from the 45 degree.
Oh,
So
okay. So that would be the
so
negative angle?
yeah, that would go in this direction. Like if I went this way, let's see if I do it in purple.
You're not
I can.
connecting.
Oh yes. Oh man. If I went this way, as I am showing you, if I went, I could also, like I'm spinning this direction, I can also go in this direction, backwards. That's in the backwards direction. That's negative 360 degrees. So the way you figure that out is just go, well, what if you say 45 degrees take away 360, right? You'd get a negative answer. That'd be your negative one. Negative 315. So basically, in a nutshell, to make it all this easier for you, to find a coterminal angle to 50 degrees, you can add 360. Okay, and that'd give you 410 degrees. That's coterminal. Just add 360. Or you can subtract 360, right? You take away, it's going to be negative. That would be negative 310 degrees. Those are both coterminal angles. You just add 360 and take away 360.
Okay, thank you.
All right, you're welcome. Okay. All right, so I have Stromer, since it's John's class, I'm going to have John do his question next, unless John wants to wait.
I can wait.
All right, Stromer, what's your question?
No, I just have a personal question for the last night I was trying to finish my homework because I remember you said on Monday was the last day to turn in work at 12, and I was trying to get work done at like around 2, and it said Delta Math and the work in our class for second period was all locked. I emailed you on just emailing normally, and then I messaged you on Canvas, and I didn't get anything back.
Yeah, I haven't had a chance to look at it. So what? So wait, you're doing it till 2 in the morning?
No, what? No, at 2 p.m. Like right when
Oh, the Delta Math, really?
Yeah, it said it was locked. I was trying to do it. It just said the teacher.
Okay, which one were you doing?
The polar coordinates, I believe.
Okay, let me look at it.
Because he said we had till Monday to turn in anywhere.
No, I know. I'm looking at my records here.
I kind of have the same question. It's just I finished like a bunch of assignments last night, and
Yeah.
like it was before the thing, but I tried emailing you, but you didn't answer, so I was like worried that
Well, let me get
that it
Strummer's
wouldn't be
first.
great.
John, let me get Strummer's first. And so I can focus one at a time. Don't worry, don't stress about it. We'll figure it out. Strummer,
Yeah.
let's see. It was the polar coordinates one?
Yeah, I was trying to do that one.
Strummer,
Yeah.
do it on time next time.
Okay.
This is a lot. You've been doing this a lot. Okay. So guess what? You have until 8 p.m. tonight. Get on it.
Okay, we'll do. Thank you.
Don't leave until you're on it. Okay. Make sure log into it right now.
All right. Let me just
Get it done before 8 p.m. Finish it within like an hour or so. All right,
okay.
John. Which one are you looking at?
So I emailed you. Let me see. What I wrote.
On Canvas?
Yeah.
Okay. Tell me what your email said.
So I have assignments that are turning in the Delta Math 8.3, 8.1, and 8.2. And then the assignment that says 44, 45, and 46. And I turned those in, but I was just worried that you wouldn't grade them.
Oh, I haven't graded yet.
Okay.
Let me see. Let me see if I got them. So you turned them in though, right?
Yeah.
Okay. Which I got 6.1s, 7.2s. You said the 8.1s?
Yeah, 8.1, 8.2, 8.3 for the Delta Math. And then
Oh, Delta Math. Okay, hang on. Do me a favor. Okay. Okay. Go to the Delta Math right now.
Mm-hmm.
And I want you to screenshot those assignments that you did, and I'll enter those right now, okay? Let me get into my grades.
Tell you the score, because
I want you to no, just present. You know how to present? I'll show you how. It's not that hard. Tell me when you're ready.
All right.
Let me get. Okay, there's the delta. Okay, I have it in my grid. Okay, let me get to you so I can look at you. Okay, you ready?
Hey.
So you see on the right, bottom right, it says present now.
Yeah.
Click on that. Oh, okay, are you presenting?
Yeah.
Okay, cool.
So for the polar,
I see it. So show it to me, man. Show me the 8.1. That's what I'm looking for.
Okay. I got 92.
Okay, cool. Hang on. Which one is? Oh, my little thing's in the way. Triangle. Okay. Okay, hang on. Let me enter that. Okay, what else you got?
8.2, which is 92 again.
Okay.
And then I got 8.3, which was 100.
Okay.
And then if you're gonna grade these all together, but I got the 100 for the test that we did.
Yeah, I haven't entered those yet for anyone, so.
All right. And then for
Oh wait, hang on. Entered the wrong one. Let's see. Okay. All right. What else?
And then I turned in